Chapter 5, number 14. The v sub x versus time graph for a 1.8 kilogram object is shown in the figure. A single force acts on the object, and the force has only an x component. What is f sub x at 0.5 seconds, 2 seconds, and 4 seconds? So at what times? At 0.5 seconds, at 2 seconds, and at 4 seconds. Those 3 times. And our key bit here is going to be that since only a single force acts, then the net force is that force. But always the net force is the mass times the acceleration. So if we can find the acceleration, we can just multiply it by the mass to get the net force. And on a velocity time plot, the acceleration is the slope. Remember, the acceleration is to velocity, what velocity is to position. So on a VT graph, the slope is A. So I really just have to compute the 3 slopes. So I take this, the slope of this line, because this is the one I care about, and I end up with A1, and I'm going to take between that moment and that moment. So 4 meters per second at 1 second, and subtract the 0 meters per second at 0 seconds, and that's just going to be 4 meters per second squared. And therefore F1 is going to be the mass times that, so it's going to be 1.8 kilograms times 4 meters per second squared, which is 7.2 newtons. And then for object, for time 2 seconds, we're at this moment, so we're going to take this slope, and I'm going to pick the moments there to be, because they're easy to read, I'm going to say I have 2 newtons at 3 seconds, and I'm subtracting off 4 newtons at 1 second, so I get minus 2 newtons over 2 seconds, or minus 1 meter per second square. So therefore F2 is going to be 1.8 kilograms times minus 1 meter per second square, or minus 1.8 newtons. And then for the last case, we're here, and I'm not going to do any calculations. I'm going to say, oh wait, clearly A3 is 0. The velocity is constant, so its slope is 0, so its acceleration is 0, and therefore F3 is also 0.